So we've looked at limits. Now let's look at derivatives of exponentials. Turns out that the derivative of e to the x is just e to the x again. So it's got a very easy derivative. It's its own derivative. And then if you've got e to the u, where u is a function and you're differentiating with respect to x, so u is a function of x, then you get e to the u times the derivative of that little inside function u, du dx. Or if your u here, again, your u is equal to some g of x. So alternately, we could say derivative with respect to x of e to a function g of x is e to the g of x. So same thing again, but then times g prime, derivative of the inside. So let's look at some examples here. We want derivative with respect to x, e to the x squared minus 2x. Well, that's e to a function, so the first thing is to do e to that same function, x squared minus 2x, and then times the derivative of this inside function. So times derivative x squared is 2x, derivative negative 2x is minus 2. And there's that derivative. Let's look at another here, example 7. We want to differentiate the square root here of sine x e to the negative 2x. Well, we've got multiple rules going on here. The first thing we want to do is change that square root to a fractional exponent. So this will be derivative with respect to x, and then we'll have sine of x e to the negative 2x, and that whole thing gets a 1/2 power. So this is going to be a power rule for functions, and remember that if you've got a function g of x to the n power, and then you find the derivative of that, so the prime, you get n g of x n minus 1. So exponent comes down, decrease exponent, and then times g prime of x, derivative of the inside. So that's what we want to do here. So that 1/2 is going to come down in front. Inside stays the same. Sine of x e to the negative 2x. Now decrease your exponent. 1/2 minus 1 is negative 1/2. And then times the derivative of the inside. So derivative with respect to x of this inside function. Sine of x e to the negative 2x. Well, let's pull this derivative off, and let's do that separately. So down here, let's do derivative with respect to x of sine x e to the negative 2x. So we're differentiating sine of a function. This is a composition. This is a derivative of f of g of x. And remember, if you're going to do the prime, the derivative of f of g of x, that's going to be the chain rule. So derivative of the outside function f prime at the inside, g of x, and then times the derivative of the inside function, g prime of x. So the outside function is sine x. So f prime, derivative of sine, is cosine. Inside function g of x is the x e to the negative 2x. That stays the same. And then times derivative of the inside. So times derivative with respect to x of that inside, x e to the negative 2x. And then what rule are we going to use here? Well, that's a product of two functions. So we're going to use a product rule there. So this is our f, and here our g. So in the next step, this is going to be cosine of x e to the negative 2x. And then times, and we need here an f prime g plus f g prime. So f is x, derivative of x is 1, g is e to the negative 2x, And then plus f is our x. And then g prime, well, this is e to a function. So you get e to that function, negative 2x, and then times the derivative of that inside function. So times negative 2. And so there's our derivative of this inside function. So next step, we've got that 1/2 sine of x e to the negative 2x and a negative 1/2 power, and then times this down here. So that'll be cosine x e to the negative 2x, and then times 1 times e to the negative 2x is just e to the negative 2x. And then this minus 2 we can bring out in the front with that x, so it will be minus 2x e to the negative 2x. And so that's a simplified derivative of the inside there. And we've got it. So multiple rules going on there. We had power rule for functions, we had chain rule here, and then we had product rule for the smaller inside function. Whew, we did it.